Last episode, Ep 17, you played the attacker. You nudged URL length up, slipped an HTTPS token in, and watched recall sag as the detector got dodged. Then you hardened against it. 17 episodes, 17 lessons. Today we stop building parts and ship the whole thing. We take the same phishing model we've carried since Epo 2, Seed 42, PRAUC 0.934, and we wrap it in everything. Rebalanced for the rare class, stopped early, constrained to respect security priors, calibrated so a score means something, threshold tuned to a false positive budget, and SHAP explained so an analyst knows why. The misconception we kill today is the biggest one in the course, that a detector is a model. It isn't. A model is one line of this file. A detector is the whole pipeline. Start with the lie people tell when they demo. Here's my model, 97% accurate, ship it. No. A model that outputs a score is a component. What ships to a SOC is a decision system. It has to decide per event, do I block this automatically? Do I send it to a human? Or do I let it pass? And it has to do that inside a fixed alert budget with a reason attached. We've built every piece separately. Today they snap together in one order, and the order matters: rebalance, then constrain, then stop early, then calibrate, then threshold, then explain. Skip a step and the thing on top is standing on sand. Piece 1, imbalance from Epo 3. Phishing is the minority class, trained naively and the gradient barely notices it. So we set scale pose weight to tilt the loss toward catching attacks. The misconception: the model will figure out the rare class on its own. It won't. Left alone, it learns that guessing benign is almost always right. The number that kills that, with the weight on, the pipeline's recall on, held out phishing reaches 0.86. Without it, it collapses. One knob set before anything else. Piece 2, priors from Ep 14. Domain knowledge says some features can only raise risk. More subdomain count, more entropy, never makes a URL safer. We hardwire that with monotonic constraints. The misconception: more data lets the model learn the right shape. Maybe eventually, but a quirky overfit can make high entropy look benign on some weird fold. The constraint forbids that fold. It costs us nothing on PRAUC, still 0.934, and it makes the model resist exactly the adversarial wiggle you saw in Ep 17. Piece 3, stop smart from Epo 7. We pass an eval set and early stopping rounds. So boosting halts the moment validation PRAIUC stops climbing, instead of memorizing the attacker's noise. The misconception: more rounds is safer. It's the opposite. Past the sweet spot you fit the test set's quirks. Here it stops around 180 trees, not the 2000 we'd have wasted, and validation PRAUC sits at 0.934. Piece 4, calibration from Ep 15, and this is the one nobody respects. The misconception said with total confidence: XGBoost outputs probabilities. It does not. Raw boosted scores are miscalibrated. A 0.9 might really mean a 60% chance. For auto containment, that's a disaster. You can't auto block on a number that lies. We fit isotonic calibration on a holdout, and now 0.93 means a real 93% chance of phishing. That's what makes the next step legal. Piece 5, the threshold from Ep 13, the most operational knob there is. The SOC can absorb maybe 150 alerts a day, no more. So we don't pick a threshold by gut, we sweep it and read 2 operating points off the PR curve. A tight one at score at least 0.93 for auto block, where precision is 0.98. 98 of 100 blocks are real, so automation is safe. And a loser one at 0.40 for triage, which together with the block tier catches 86% of phishing at a false positive rate of 2.4%. Everything below 0.40 passes silently. 3 tiers, 2 thresholds, 1 budget. Piece 6, the reason, from Ep 12. Every auto block carries a SHAP explanation. because a block with no reason is an incident waiting to happen. Across the whole block tier, the top 3 drivers are has HTTP is 0, high URL entropy and high subdomain count, the same signals a human analyst would circle. The misconception, the score is the answer. The score is the trigger. The reason is the answer. Put them together and you have something a SOC will actually turn on. Open 18 SOC pipeline.py. It's about 60 lines and it is the course in order. We rebuild the FO2 house dataset under seed 42, split off a calibration holdout, train one constraint XGBoost with the imbalance weight and early stopping, calibrate it, sweep the threshold to find our 2 operating points, bucket every test event into block, triage or sparse, and compute the SHAP reasons for the block tier. 6 libraries, no downloads, runs in Colab. Lines 122, the house dataset frozen, make classification with random state 42. Then we rename the columns to the real phishing features. URL length, num dots has HTTPS, subdomain count, URL entropy, domain age days. Same generator, same seed as FO2, so PRAUC lands at 0.934. We carve out 3 splits, train calibration holdout test, because calibration must never see training data. Lines 24-38, the constrained balanced early stopped model. Scale pose weight from the class ratio handles imbalance. Monotone constraints pinned subdomain count and overall entropy to +1, risk only. Aval set plus early stopping rounds down 30 alts at funbow 180 trees. This single fit call carries 3 of the 6 lessons at once. Lines 40-47, calibration. We wrap the trained booster in calibrated classifier CV with method isotonic. Fit on the holdout, and from here on we only ever read predict proba. Now the score is an honest probability, the prerequisite for thresholding into automation. Lines 49-60, the threshold sweep and tiering. We compute the PR curve for the headline PR IUC BOVA 0.934, then route every test event, at least 0.93 to block, at least 0.40 to triage else pass. We print per tier precision and counts and confirm block precision 0.98, combined recall 0.86, FPR 2.4%. Lines 62-68, the reasons. We run SHAP.tree explainer on the raw booster over just the block tier events and take mean, SHAPFOW, per feature. The top 3 has HTTPS, URL entropy, subdomain count. Become the standing explanation panel for everything the pipeline auto blocks. And that's the whole arc, honestly told. A shippable detector is never a model. It's a model that's been rebalanced, constrained, stopped early, calibrated, thresholded to a budget, and made to explain itself with every number tracing back to one seeded run. You started this course thinking deep learning was the obvious choice for telemetry. You're ending it able to stand up a gradient boosted detector a SOC will actually deploy. That's the series. Go ship something that catches the bad guys and keep an eye on that PR AOC because the attackers in F17 aren't done. Thanks for watching.